So from a version number standpoint, so far, right, what we have been doing is we maintain version 0.40. Look at all the bundles. All the bundles are 0.0, except one bundle. This sal bundle is 0.50. Right. We have actually there's a debate that's been happening on in the forum now on how to have proper versioning numbers for this. Okay. So uh, look at a system like OSGI. In the OSGI runtime system, any bundle can be at runtime stopped, started, inserted, removed, so on and so forth. Right? So it's not, it's like in-service software upgrade. You can have patches, you just upgrade the patch without user of the entire system now. Right? So in such a system, dynamic system, the APIs should not keep changing. Right? If the API changes, then the contract that you had with another bundle will change. So again, you're going to break the entire system. Okay? So the one that they are following at this point, the principle that is guiding the following is that if you change an API, okay, you have to bump up the minor version. Look at there's a major, minor, and the micro version. Okay? So we are clear on when to bump up the minor and the major, but we are not clear when to bump the micro version. Okay? So minor version we want to bump whenever there's a change in APIs in any of these are exported functions. Okay? Whenever there's a change in exported APIs, any of them, we have to bump up the minor version. It's very straightforward. It's both because if it's not a private function, if it's an exposed one, there is an assumption by the other bundle on how it's going to work, right? From syntax wise, it's a no-brainer. We have to check out, right? So it's systematic, very critical. Correct. That is exactly where we are confused about when to bump the micro version and minor version. Right? So it's what a very valid point. So let's go into the code, right? Then you will be, I can explain much better. It's very abstract, so I'm finding it very hard to explain that. Okay, that's at a very high level, right? If you look at OSGA as a system, by the way, I'm not doing a OSGA tutorial here. I just want to give a very high level picture on what OSGA is. I recommend everybody to go and read on OSGA because that's the system is running the entire controller. If you have a good understanding on OSGI, it's much easier to look at the code to configure it. If not, it's very difficult for you to even put the pieces together. It's very difficult. So my recommendation is take an OSGI book, then really good books on that, and then just go over that. It's pretty neat. So OSGI framework as such is built upon these fundamental architecture principles. So we are taking for granted about JVM and operating system, right? So in order to get the entire ecosystem to be in place, so modularity is the key. That's why I was trying to explain why modularity is essential. Without having a model system, we cannot have a life cycle for a given bundle properly done. Right? So the model is not properly defined. If it doesn't have a proper exposed API, if it doesn't have a version, we cannot do a life cycle properly. We cannot do a life cycle by reloading a given bundle at runtime. We cannot do that. So that's why we need proper principles on every layer. So service registry is one thing where services, since we are talking about reloading a bundle at runtime and having a loose coupled bundles, we need a proper service registry where every bundle when it comes up, it exposes what a service it provides and what it consumes. So we need a layer called service registry layer which maintains the services exposed and consumed. Okay? So that's the layer that we have. Security is another. It goes across the system. We haven't enabled on the existing controllers. We won't see a secure principle on the code edge. So we have to work together to make it secure. Security is one thing where we can potentially have assigned jars by assigned bundles to be part of the controller rather than having arbitrary bundles getting public. There's nothing like that today. So mostly we have an app store like an Apple App Store where you can download bundles and you can start using it. But we don't have it anything like that at this point. But that's a good idea. We can have OpenDaylight where you can have multiple apps as bundles. Anybody can download it and attach to it. Yeah. Yes. So if you look at the uh, Equinox framework that we use, in here we use Equinox framework for the OSGI, right? So the Equinox framework load, we look for a folder by default called plugins folder. In the plugins folder, whatever bundle is there, we load, try to load. That's what it is, right? So every bundle has its own dependency graph. So first it forms a dependency graph. Based on dependency resolution, it's going to load bundle one after another. And it also has the bundle sequencing, all those things. I show the code. I show the code on how the bundles are loaded at runtime, how the bundles can be removed and restarted. So if you look at the final delivery of OSGI, when you go to the Access and start a build or a Maven clean install, you'll see that the final delivery is a zip file. Okay? If you unzip the file, you see that there will be a minimal scripts on the plugin folder. Go to the plugin folder, you see all the bundles. Okay? So let me show that to you. Right. So I'm the folder here. This is the entire code is here. I'm going to go into the distribution folder. Okay. So go to target distribution. Okay. So look at the OpenDaylight. You see a plugins folder here. Okay. The plugins folder is where you get all the bundles that will loaded. Everything's right here, from OpenDaylight controller statistics to everything. Okay, so this is a very high level picture about what is the underlying framework of this controller. We haven't even touched upon controller as a marketing standpoint. This is the underlying framework that we have. For there, you can have a lot of plugins to be part of that. So we mix a lot of different plugins like the bundle plugin to finally create a bundle for us. Instead of rewriting a complex manifest file, as the person asked the question, it's very complicated to write a manifest file. It is, because you need to expose a lot of export packages and import packages. So the plugin. So if you look at the wiki page, we have listed the outbound APIs exposed by the controller. Outbound API, the documentation is automatically generated by the user. So we write the code in Java, in Jersey framework, and we have an initial plugin. It generates an outbound API, right? And we use Gatsby for for the marshalling and demarshalling. So we use a lot of such various frameworks for building the control as a whole. Okay. Um, okay. Yes. Um, One good thing is you build will fail. It's not dependent, it's not compatible with it. Right? That's the idea of one of the good thing is if you don't do public version, if API comes up, you're gonna fail at the runtime, because at runtime you will try to log in, try to hook onto a different version, it's gonna fail at the runtime. So from an OpenDaylight consulting standpoint, the reason that we have proper code reviews happening on the code is because if somebody writes a code and commits by bumping up not bumping up the version, they change the APIs, you have a flag saying not can't go into the code. You have to bump up the version and then you can go inside. The moment the version is bumped up, right, when the API changes, it's straightforward after that, because when folks wants to make this a different bundle, they have to explicitly state which bundle and which version is different upon. Right? So if the committer from the code, right, who changes the APIs, they make sure the bundle version comes up, then the consumers have no problems. Right? So the entire load is on the person who is writing the code and committing open data. That's why the committers, right, I'm a committer, I make sure when the code goes in, we review it and make sure you don't get such code inside. It is a complex topic. Right? Having a system like OGF system and not maintaining this version compatibility is a very complex one. It's nothing new, right? It's like DLL and COM, we all know that API changes and try to load a different DLL in the system is going to be exactly the same. Okay. Nothing like that, right? But it's not a bad idea, right? Since you use Maven, right? In Maven you can have plugins. You can develop a plugin and then say, hey, if API has changed, we can't let the build to go through until you very well. But the question that he asked is very valid, where what if syntax is not changed? Semantic improvements, right? That any system cannot catch. Only code reviewers matter to them. Right? Yeah, yes. Um, Unfortunately, I don't have a slide deck on the architecture of the controller itself, right? So let's go to the code. I'll go to the code and then I'm much comfortable on the code. So we can start talking about the architecture. So once you download the code and import it in Eclipse, I'm an Eclipse guy. I use developing in Eclipse. There are a lot of guys who don't use Eclipse, they use whatever data they have. So if you look at the controller, the code base, you make sure you work better in Eclipse editor. Like all the tools needed for Eclipse, also on the command line. So Maven is compatible.
You guys go ahead. Oh,
yeah, sure. But it's not a problem. It's all. Oh, friend, sorry. Fine now? It is not. Okay. Small. Okay, so these are all the bundles that we currently have. If you look at Eclipse, it's all different projects. All these projects or these bundles make this gigantic controller. So we see everything from our pandas to custody services to everything that you see on the code right here. Now, let me start going through some bundles so that we can start thinking about this. Let's go from distribution. This is the key. So distribution OpenDaylight is the bundle where you define what are the bundles that go into a given distribution. We have a form file here. So I'm assuming most of you guys know about Maven. So Maven is the base system for embedded guys. It's like Makefile, right? It's a highly advanced version of Makefile for them. So everything in Maven is form files. So whatever you define in form is going to get executed. That's the system. Not actually in this stuff. Okay, as this is right. Right. Distribution. All right, there you go. So this is the the main POM file that when you do a build, main install of the go to the runtime system right here. We have everything enabled here. You can do a OpenDaylight assembler. It's going to go and consult this particular POM file and pull every bundle from these folder locations. Right? It's going to pull everything together and it's going to build as a one JSON package. That's what I want to do. So, if you're going to develop a bundle for testing or whatever, you can build the bundle and put it in point the location here, and it's going to build for you and get packaged in your file. As you can see here, we have separated them out using SAL bundles, web bundles, northbound, and apps. Everything is separated out just for convenience. But as I said, right, at runtime system, every bundle has its own equal. There's no difference between one bundle. There's absolutely no difference. This is the distribution OpenDaylight form.xml. This is the first one that anybody interested in the build try to look at this one. From here, you can go and see what are the bundles make the system, and you can start doing the code block. Some bundles are not even part of the system. Just you can runtime, you can plug it in. So if you want to know what are the bundles, it's the one that you can start. Let's take an example, and then I'll show a simple structure of a given bundle, and you can see the same structures get replicated in every other bundle. There's no difference. But if you want to write if I want to write a bundle, what I typically do is I go to a simple bundle and I clone that and start modifying it. I don't write everything from scratch. I never do that. Okay? So it's same for all of any one of us. It's straightforward to do that. Let's take a look at our panel, for example. Our panel has a form file. Okay. So whatever you see the Maven bundle plugin, this is specific to OSGI. Okay? In OSGI, as I was explaining, you have to import the services and export the services that you expose. Unfortunately, this bundle doesn't expose anything, so we put another bundle. You see first. This forwarding goes into this will have everything. Okay. This is the forwarding rules engine. Forward rules manager. Yeah. All right. So this is the forwarding rules manager's API bundle, not implementation bundle. API bundle is where we expose the APIs. Implementation bundle is an internal one. We don't export it. Implementation. You can see here the bundle plugin. We have the export packages of all OpenDaylight controller forwarding rules. Okay. If you have any other package internal, it's not exposed at all to anybody outside. Sitting outside this bundle. And we had explicitly defined what are all the packages that we import. So as you look at here, this package, forwarding rules engine, depends on clustering, configuration, post tracker, switch manager, and a lot of SAL packages. Right? But it doesn't depend on topology manager, for example. So when there's no dependency like that, topology manager, reloading the topology manager will have zero impact on the forwarding rules engine. Clearly visible. Right? So as you can see, look at this particular form file, you clearly know what this bundle is dependent on and what is the version that we worried about. As you can see here, this is a package version. When I scroll down, you can see that we put the dependency also here. The dependency clearly mentions what is the version that we depend on. Right? Okay. All these versions are all in Maven. Right? So we have a Nexus sonotype with the Maven repository. So we just pulled in dynamically. So we build it, we'll go to the OpenDaylight, you will get it commit, right? You'll see that these bundles are developed and put it in the Nexus repository. So if you want, say for example, if you want to develop your own application, you don't need the entire code base to be part of your build system. As an example, so this is something which I developed. Right? There's a lot of applications I'm developing using the OpenDaylight. As you can see, the number of bundles is still less here, right? It doesn't even have all the OpenDaylight bundles here because we don't need it because since we are Maven centric, Maven automatically download the bundles for you, right? So that's why we have tried in this Nexus type where it's OpenDaylight. So Nexus OpenDaylight where you see all the bundles version and part of the repository. So if you're developing a bundle, just declare dependency here. You'll be automatically download all the bundles. Oh yeah, that's the one. So our purpose we have it. So I can go and show it. Okay, it's in distribution.OpenDaylight. Yeah. If you go inside, you see perfect red. Yeah, so the distribution OpenDaylight is the base one. When you start the build, that's where you go and fix that. After that, it's going to show all the different folders right here, forwarding, static loading, and everything, right? So it's going to go into every different folder and pick up the POM file from there and do the dependencies. Everything is done. It's like a hierarchical one. Okay? No, it's related, right? So it will be. I'll show you the folder. So right here. So if you go here, right? OpenDaylight. This is the base. If you want to download this, all you see all the code is right. These are all related to the distribution. So I was showing the forwarding rules manager. So in the forwarding rules manager, the API bundle exposes the API, the package that contains, and it imposes various different bundles. And the dependency is going to clearly define what version of the bundle is dependent on. Okay, that's the troubleshooting stuff, right? So the version is different, or you may not even have an internet connection where you can download the same plugin. So we'll look at that. So Maven, you need to tweak some stuff, right? By default, Maven will work great, but if you are custom sitting on Maven, you have to tweak some stuff. Yeah. We have a quick discussion on the forum 2 days back on same time. If you get interested, right? We have a pre-built VM, and we can download and see how everything is. All the code is there, the topology is there. No, the code is there, right? You can always update it. The code is there. So just do a git pull, you get the code. So I think the VM, the environment is set properly. We have all the mail installed properly. We have the mainnet in place. But if you have questions on Maven, we can take it up. So you have to go manually. So this is not just this is a time-consuming work for us. Right? You have to manually go and do it, but it gives a real it's a value to me where as a developer I make a lot of mistakes. Right? I try to write a lot of code without understanding dependencies. But when you go and see here, you clearly know what is dependent on. If you're unnecessary dependency, you can go and pull it out. It's really a good system to have. At this point, it's manual to do. This is clear writing manual. All this stuff. So once you see when I write the code, right, I don't first go fill this form first. Right? I'll first write the code. I do the build is fail, right? Now I know, hey, what I'm dependent on. I go back and write those packages and bundles. That's how I do it. Right? It's very difficult for you to everywhere think, hey, what all I'm dependent on and start writing. So you start editing. Once you start editing the code, it's very evident for you. Where you write the code, you have a design, keep writing the code. You're done. This will fail for sure. Then come back, put this packages, then it will work. So that's how you should move forward. So I was showing the forwarding rules manager form file. Let's go to the actual code now. If you look at the code here, this is just the API code, API bundle. It has no actual code in place. So let's go and look at the I forwarding rules manager Java. All it has is some few functions defined. It's all interface, not even a class. Right? So as you can see here, this is a documented, well-documented APIs. So any bundle dependent on anyone who want to do any flow programming, they have to use this bundle API. But as you can see here, this bundle is not doing anything useful. It's just that's it, right? What we have as a standard in the OpenDaylight controller is that every API bundle will have a corresponding implementation bundle. So the idea is implementation sucks can replace the other implementation without changing the API. If you don't do that, then you are dependent on the API implementation type. Okay? So we have a corresponding implementation bundle here. Look at the form file here. You can see it's not exporting anything. That means this bundle cannot be called directly by any other bundle. It's not exporting anything. It is just consuming it. Right? But at runtime system, the binding will happen. So since this is the implementation bundle, when somebody is dependent on forwarding rules managed services, he will say, even though I don't export any packages, I export this service. That's why service is very important. Okay? So now if you go to the code, internal, you see this activated Java. Okay? So activated Java is the most important thing for all of us to start looking at. It's like the public static void main in Java or main function. This is exactly where your code will get called when the bundle is loaded and loaded everything. This is the part. So look at the Java OSGI as a very base system without Spring VM and all those cool technologies. Activated is the base. It's really the base file which will get your bundle up and down or restarting or whatever. This is the file. And there's a lot of work to be done on this one. So we actually wrote most of the code in component activated abstract base. If you get interested, take a look at it. It's very interesting. Okay, activated Java will be inside the implementation bundles, not in the interface bundles. If you're looking at forwarding rules manager, look at forwarding rules manager dot implementation. That is why we see activated being defined. Okay? It is per bundle, yes. For implementation bundles, because implementation bundles are the ones who are going to really work. The interface bundles are to give you the proper interface. Right? So you will never see the activated Java. You can see it, but there is no need for activated Java in the interface. So if you look at all implementation bundles, for example, right, let's go to testing services. Testing services also will have activated Java right here. Okay? So every bundle must activate itself and tell the system what it exposes. So in this case, we are looking at the forwarding rules managers activated Java. Here, we have to define what is the implementation file that it's going to call. Activate is just the interface to the OSGI layer. And the magic happens right here. Okay. As you can see here, we have separated into two layers here. One is set interface and the add here. Okay. Whenever you do set interface, that shows that what are the different interfaces this particular bundle exposes. Okay. As you can see here, the I forwarding rules manager class. This is the one defined inside the API here. There you go, right? So here they are stating that this implementation bundle exposes those services defined by I forwarding rules manager. This is exactly where the timing happens. So this is actually a complex topic. The dependency management is a very complex topic in Java, in OSGI. We made it simple by writing this file activated Java. So one more thing is this is the reason why we went this approach. there's another concept called string DM and the service where you can define the XML file instead of writing code like that. You can define everything in XML file and make the system take it up and start doing it. The problem is with the XML file, it's not advanced yet. The resume is very old. Where what's happening is we wanted to add a concept for container. In a container, multiple bundles of different instances on top of each other. Okay? We want to choose the bundles of different containers together. That is not possible with XML. Okay? That's why we didn't want to go with that approach. No string DM, none of those concepts, and we went with hardcore Java. No XML files for defining these independent. Okay? So finally, we are looking at the forwarding rules manager implementation inside the source. Every implementation bundle will have internal folder. Rules manager. It's not the same package. Oh yeah, yeah, because it's defined in imports, right? Yeah, you import everything. In this case, this is the imported one. The imported. The reason it's imported is because the previous bundle, right? It actually had an export stating, hey, I export this package. Okay. Say if you remove this package from here, this will fail. This call will fail because the service exposed by the other bundle is only you can import it. If there's no export there, you cannot import it. That is the situation that we have in OSGI. So we make it that approach of OSGI to make sure you can have a separate API bundle which expose only API, an implementation bundle which can expose the services exposed by the API. Is it clear or the complicated? Clear? Okay, so if you look at any bundle, you see the exact same structure. You see the Git implementations, the forwarding rules manager implementation. This is the actual code. You want to have a code that's going to expose these services. This is the file. Forwarding rules manager implementation, and configuration is going to give you all the interfaces that this exposes, services this provides, okay? And here, what are all the dependencies it has? So if you define the dependency at a compile level in the form file, right? Once the Maven is done, Maven is only at a compile level. At runtime, Maven is not even there. Maven is out of the picture. At runtime, it's all OS. Okay? This is the runtime behavior where once the compiler system says, okay, you are good to go, right? That means your compiler dependency is perfectly validated. That means when the runtime system starts, this bundle starts loading, the OSJ will start resolving the dependency and say, hey, you are dependent on that person, you have to wait till later. So only the least dependent bundle will get loaded first. And then as the dependency getting resolved, other bundles start loading. And when you say loading, in Java there's multiple layers. When it's init, start, multiple layers are there. The start is one, when you say bundle is loaded, start is one. Your bundle won't get started until the dependencies are resolved. And when I create a dependency, the bundles are all loaded in their own class, in their own class order, right? The OLJ system is going to call you back with callbacks stating this is the object reference for a given bundle. So as you can see here, I'm creating a dependency here stating I am dependent on iProgramer service, forwarding rules manager aware, iSwitch manager, right? I'm explaining what are the dependencies. The moment OSGI loads these bundles and dependencies are resolved, what is going to happen is when I go to this implementation file, okay. So all these functions get automatically called by the OSGI system. As the switch manager gets resolved, you will get a callback inside this forwarding this implementation stating switch manager is resolved, and this is a reference for you to start calling the service. That's this idea. So you define it here in the C add services saying what is the callback. So the callback for iSwitch manager is the switch manager, and the implementation is defined in the implementation array, and this will get called automatically. So once all the dependencies are solved, all your callbacks are done, you set your references. Finally, you get the start callback or the in callback. We have a start also. Okay, so everything is done. So from a bundle standpoint, you have to make sure your activator is properly defined. That's when you define your what you expose as interfaces and what you consume as a dependent. After that, you have to set proper callbacks on these activators to the access implementation file. Once you are done, once the system is completely loaded, once everything is resolved, then you are good to go. After this, if you look at the entire code here, where is the override? These are all overriding by the service, right? Just look at the yeah, the Equinox. Correct. From the Equinox. So that's if you look at the system, right? We made it less complicated. Actually, it's a very complex system. This is very complex, complicated from an architecture standpoint. Look at the component activator abstract base. It does most of the work for you. It's called component activator abstract base. It's under all OpenDaylight style code. Uh, we depend on Apache Felix dependency manager. Even though we make use of Equinox for our runtime system, we use dependency manager from Felix. Okay? Dependency manager does all job for you, and this is a very complex topic. So that's why we abstract it out for the component abstract base, and we made the actuator simple by just extending from there. If you want to write your own actuator from start, from base, very complicated. We'll take care of all this various various stuff. Equinox is a framework, right? Equinox is the base framework for OSGI. When OSGI came about, right? Equinox is the guys who brought it up, and any OSGI specification will get first implemented in Equinox. Then you go to the Felix and others. So that's a definite implementation for OSGI. No dependencies. Yeah, no. This stuff what? This stuff switches. Okay, so that's exactly what I was trying to say before, right? In a, it's possible now where let's go. So this is I want to show the container structure. Okay, so here we are not talking about Pojo. Okay? In a Pojo object, right? We're talking in a Pojo we talk about a given object we create, and this is like an employee, right? You create an employee instance and you have multiple employee instances as you have. Anyway. Here we're talking about services, right? Body must manager service depends on switch manager service. Okay? Switch manager service can have multiple nodes, multiple switches. That's a Pojo object. It's clear, right? But the dependency that you're talking about is not service dependent, not Pojo dependent. Service dependency, you do not see multiple forwarding routes manager services running for the same container. You do not see that, right? For a given container, there is only one forwarding routes manager instance. Okay? But for multiple containers, we have multiple containers. If you look at the system here, it's a container-based system. Container one can have container is a concept where you can have your own controller, separate controller. So in the same runtime Java JVM running, you have multiple controllers. one container can run all the bundles that you see. Another container runtime can run another scope. Okay, so when you talk about dependencies, you talk about service dependencies. It's one instance of a service per container. So the problem is possible. So we have properties you can sit in properties in containers. So we call it properties. It's not me. It's OSGA calls it properties. Okay. You got service properties right here. So you can pass container name is an example, right? So you create a virtual tenant. You call it the Microsoft or whatever, right? Then that information you can pass to a given container. You container instance using the service properties. Yeah. Okay. Okay. I'll do the real reason behind it. Right? Say I'm embedded student. I used to be. Most of us when we start developing, right? Spring is supposed to ease your work, right? Write XML file, but Spring really complicates things in an OSJ. Really complicated. Okay? Because Spring and OSJ got this similar work. Okay? So the Spring framework came with the concept of Spring DM. Okay? That is the infrastructure. That's the framework to make OSJ supposed to be made easier. Okay? But it's really complicated, really bad. And Spring DM is being they're not maintaining anymore. This is not whatsoever maintained. And I'll give one very important point. Spring DM added 25 stack frames every call, every OSG call. Right? So if one bundle wants to call another bundle, you can see a 25 stacks being called just based on this. Right? Its cost performance really degrades really bad. Right? So as an embedded system engineer, I really look at all those performance bottlenecks. Right? We saw Spring is not the answer here. So we removed we didn't want Spring at all. Initially we started using Spring, then we said, okay, that's not once we saw the stack frame exploding, we removed it. After that, we see that every function call from one bundle to another bundle is a function call. It's not a hooks to call to Spring D. So this performance and complexity we removed. And we still have Spring MVC on the UI components. Okay, but we want to remove that also. We want to make the UI as a client side MVC and keep the SAP around talk to it. But if you have a good point about Spring, please do it. Okay, so today companies is more of helping you. So, because I'm going much deeper than before. Right? Okay, very good. So one more thing I want to talk about in the activator. The reason I'm considering activator is because this is where people it's like a black magic for most of us. Once you go to the functional, right, the forwarding implementation, they're all domain experts. So you can write any code you want to on the domain that you write. But activator is the space where you have to be concentrate on. That's where you can make mistakes and it's very difficult to debug. In activator, we have two types of API calls. Let me go to a configuration. Okay. It's going to configure implementation. Look at the activator here. You see a get global implementation. Right? So in the previous one, in the previous activator file, you saw only get implementation. There's no global implementation. There's just the implementation and just configure instance with the container. Right? It means the forwarding rules implementation service resides inside the container only. It cannot reside as a global. There's no reason for that. So forwarding rules manager and service. By default, we have a default container. By default, so just when you run the control, right? You build it and run as a controller. You will see one UI with just one container. Just everything looks seamless. because we are running default container. Customers can actually create a new container. Once you create a new container, you create and use a forwarding implementation services, and then those will run in separate container. So a functional component like a forwarding manager and switch manager, all of them can run only inside one container. But there are components like the configuration services. To give a small example, configuration services, if you do a save config, it's taking all the configurations from across bundles and saving it in this. That's what configuration information does. This has a global significance that you don't save one config, you don't save individual container config. So as you can see here, you see get global implementations and configure global instances. You don't see a container view. Okay. So if you are writing a bundle for your own sake, this needs to run inside a container and outside a container, meaning a global instance. Then you need to override this get global implementations and get global instance. Without that, you will never see your instance running as a global service. You want to spawn across various instances, right? The question that the gentleman asked now. How do you get all the audible implementation instances across containers? Once you have a global implementation of a given bundle, it has visibility to all the containers. Right? A given container instance can fuse into only a container dependent bundles, but a global instance can look into all the bundles across the container. So that's the default distribution there. So it's component like a VTN manager. Like today we saw the example in the presentation. Right? VTN manager is a potential bundle or a DAO manager order. Right? So potential bundle, which should be a global implementation, because that's one is going to create containers and going to manage containers. So VTN manager and site, I'm doing it for site manager. We should do exactly the same. It's going to create containers, manage containers, maintain. So whenever you have a global requirement like that, then you should override the get global instances and but the rest is exactly once you go to the code, it's exactly to define the interface that you expose, add the dependencies that you depend on. Okay. Is it clear so far? Yeah. Props. Yeah. Props are different properties. So when the instance is called for, you can have a properties being called. I'll show you. I'll show you exactly how it's used. Yes, the question that somebody asked here, right? That if you have a constructor today, and constructor can have a different constructor with the parameters, but you can also pass an employee object, for example. Right? Employee object typically will have two parameters. One is the employee name, employee ID. Those two are properties or arguments passed to the instance. Properties are exactly there. Since the object is not created by you, this is created by the OS system, it gives you a way to pass properties. It's called cross-space properties. There's no difference between them. It's like a construct argument. Yeah, yeah. That's fine. I was like, so in Java, I never that is nothing. Just to how objects should be at that time create an object. At that time we create a new class, we create an object, right? We create an instance. This is one and this is another object point. This is the object. Now photos is not a good rendering, right? This is bad object. This is really tough. Now, in discussing about services or experiences in our service platform, what service, what is this person? Okay. So, typically in typical Ojo application, right? Say you are an employee, you say employee, new employee, employee not. This is not done in OSCI services. Service this is created by the attention. The OSCI you can also it is the option for you and choose the check. So these options are created for you by right? Now, since there is only one creator, what if I want two modules to be running or two running? So container is nothing but a resultant. The same difference we have in one. Resultant is there. You have you want to have their own space, they want their own programming environment, what I said is you don't want to run a separate controller like you. What is same controller, same management, but it's isolated from an object. So pattern is exactly that. So I can have multiple controllers, right? Give you an example, right? And Goldman Sachs. Customers, they all want to share the Amazon access. Now, you can create containers. On each container, you can have into the part of the manager. Into the manager. And when they use to do it, into the dependencies we define, into the constant instance, we pass the container name as a instance. So this will be this together. This will be now within a given instance, you can have all the dependencies of. So every service will have one instance per second. But you can the code the one code at this point create a container. All the instances you code is not standard. But usually you can start thinking about I can have a firewall for this start thinking about. But overall idea is a logical control. That everything is new for them. The code is open, we can put it on. But at this point, if you look at the code as you see now, whenever you create a container, you are running. So it's the container with the bundle that's going to be your bundle type of each other we can do that. So today we have containers spread across the code. Look at the code, you see containers everywhere, including the REST APIs, right? We have to pass the container name. What we don't have currently is the manager, the VT manager, site manager is not there. Once we have the VT manager, site manager, there we can exactly specify which person we want. By default today, there is no VT manager or site manager there. And then we create a container, you create the entire system, the full one. Right? Not all. All those bundles that are containers. Right? So, like an example, the custom services or let's look at the configuration service. Configuration service is a global instance. It will not be replicated into every container. So, but example of forward goes in, right?
Not breaking per instance, but for some specific instance, like a services.
Every bundle, right? Every bundle can expose whether they want to be containerized or not. Okay? Whichever bundle, as we see today, right? Whichever bundle says I want to be containerized, whenever a container is created, then the bundle will be automatically, right? What is missing is the exact what I was saying, right? You don't have a way today, right? You don't have a manager who's going to say, hey, I want to create a server service. This server service container, I don't want to know what is manager. Right? Today you don't have a way to automatically find that. That's how you kind of a manager to say, hey, I'm a manager, I'm saying this container does not need this service. It's fine. You can put it together. That's the idea of the OGI. In OGI, every bundle can say what depends on, and you can put it together. Really, very modern.
Yeah, so you're effectively finding at least visually catered on the build one.
No, at runtime. Okay. At runtime, when you create a container, all the objects are created and then start to no, today, right, by default, every bundle just say I'm container in the world, right? That's all it says. And the moment container is created, all these interested bundles are all put in containers. There is no filtering. It's right here. It's not the management code actually. The activator of Java, if you look at this configure, whenever you write code in configure instance and get implementations, that means you are interested in container. Just implementations and configure instance, right? In activator. But whenever you in the activator you say I'm interested in the global instance here, that means you are not interested in container, you are interested in the global. Yeah.
So there you have to describe it by
yeah.
When you instantiate that instance, you have to specify.
Yeah. Get implementation, right? This is when the system is going to take the class and create an object from it. Okay? But this is when actually the container is being passed. Right? So this is then by default, here the bundle is not saying, hey, I'm not interested in this container. You're not saying that, right? Especially you're not saying that. You can purposely do it here, saying the container name is not equal to firewall, right? I'm not going to answer this as part of it. Right?
So you need to instantiate a container first in advance and now assign that container name is a bigger instance.
Yeah, this callback happen automatically. You don't have to do anything. All the things automatically functions. Config is called automatically by the container manager or whatever, right? It creates the container. Right away you see all this automatically. You don't do anything. Okay? As you can see, container name is passed here. This container name is actually being passed as property. Or not here. It goes to other means. But container name is passed as part of property. That's the manager. As a manager, when somebody creates a container, they say, hey, I want to create a container for purpose. That name is passed across the window. So we can check it easily. But it's not there in the code. Because the current code, we don't have filter bundles based on which container I want to belong to. So we don't have anything else.
So basically right now, the manager asks the same on the activity.
Correct. Exactly. Container manager will say, this is the container name, it is instantiated. Everybody gets instantiated, everybody gets used like that. Right? Now we get a separate controller. Container is a logic controller. Right? But that's where the beauty of it, right? We have to write a manager's functionality. We still come and say, hey, this bundle doesn't belong to this container, so on and so forth. But you don't have it. I want to change. All right. Go on. Yeah. Right.
So some are tenant specific services which you are creating containers.
It's not a global container. It's not a global container form, right?
There's no global.
So yeah, default container. Default container. Default container is what comes by default, right? When you build the system and run, whatever you see in the UI, whatever functionality happens, right? It all happens in default.
So the container manager, I was
correct. A container manager is going to be not in any container. Container manager is the global instance. That is the one creating the default container. So when I say global, I mean I'm not belonging to the container at all. I'm superior than all the containers. Right? I can manage the container. That's all it means. Yeah. I'll go through the. If you want to go through this quickly, I can go through. I know I'm going there. Hello. See, once the container is created, it's independent. You don't need a core.
So what functions of a tenant are
everything for a container will be inside a container. It never be leaking out. It should not be leaking out.
So how would you coordinate?
Why do you want to go on? So today the container concept, today is for isolation. Today the container is for isolation. You create a container, that means you isolate them completely, right? There's no mechanism for no leaking to it.
I have only certain number. I have 5 container ones that I give it.
Perfect, yeah. That manager is going to do that. But creating a container, that manager is going to say, hey, you have resources, you have it. Once you are created, once you are done, yes, no business talking to other container.
How would you coordinate? How would you know that out of 5 VLANs, 3 have been consumed, 2 are remaining? Therefore, the new container is only used to be.
That's the job manager. The manager is the person who's going to maintain the resources and is going to give it to the appropriate containers based on the SLAs or whatever, right? Yeah, both might say, hey, I want no.
Because dynamically, certain new line card and then VLAN 3. It seems to me as if there must be an entity with dynamically expressing the resources that are there in the structure. And as the containers are being created, that container should check with this dynamic entity how much resources do I have. Do I have enough resources to get instantiated or not?
There's nothing like today. Today, once you create a container, it's in its own world. It has nothing to do with anything. So that's how it is, right? So only thing it can talk to is site manager. The manager is the one who creates the meeting manager one and creates that. After that, no business happens. Today is nothing like that. Look at the code today, you won't see anything like that.
Because right now it's everything hardware resource.
Nothing like that. You won't see anything like that, right? See, this is the deal of open source. We all work together. There's a requirement that you can right? We all work as a consortium. We all work together. See, it doesn't make sense. Makes sense with one right architecture. I'm expressing what we have today. Okay? What today we don't have that. I don't know. See, this is the first time I'm hearing that. I have no inclination to say yes or no because I don't know whether it's either. Somebody will say, hey, why should once the container should be complete and why should they even bother to go outside? They should not actually, right? The moment they say actually a bigger problem. A bigger problem is one of the architectural problems we face today is usually say tenant. Tenant means isolation. Okay? But we are running in the same address space, the same area. You know how big problem it is? It's a problem. People are saying, hey, don't even run the tenant in the same address space. I don't trust you. Right? So they're talking about that level of isolation. So there are various requirements from my tenant container standpoint. You need to look at all the various use cases. See which is fair.
Also, like all these guys
They do.
So that makes like you are isolated and then I think you're trying to sort of bigger so program something to be conservative that shouldn't be.
Right. This is what you have today is first is provide continuous facility service calls, right? So we depend on the container managers and the custom services implementation to make sure isolation is happy. But anyway, we are running the same container, right? That nobody can do. That's a problem. Right? We all agree, right? They want to space containers, isolation, it's a problem. So we are thinking about how to run different spaces, how to run remote OSGIs, to have what all this. We thought about it.
Yes, and then inside each container, you could have multiple from process memory process.
There's no process in Java. It's one process. JVM. That's it. After this, all this.
No, I'm talking about the relation to GVM. So container is above GVM, but one is we have a single GVM, or inside each container you have a single GVM.
So that's what I mean. This is one JVM. I'm explaining about today's code. Today's code is one JVM. Container is a logical entity, which isolates things. Okay? Being Java, we think isolation is reasonable, but there are strict requirements which say no, I will not trust your code to run in the same amount of space. Separate space, completely separate. That's the only option. That's the only option here, right? So there are various discussions happening. So this code, whatever code you see now, right, is what we developed and contribute to open source. But there are lots of discussions happening now. You are the opposite to what other thing, optimization, you are saying you have shared.
For the interface of application, so each container is going to expose how actually communicate with the bundle inside of the container. That's the first API.
This API is one way. This API we define which container you want to go. This API is the API, right? You see controller /northbound /b2 /container name, and then you go to everything.
Oh, that's how the container name comes out.
Default, that's okay, container is part of the API to work. That's the one. It is default is the only thing we put default and move on, but that's where it comes in. But if you look at the OSGI code, again we need containers. Again, only containers you can do a few things. You look at this one, right? How can foreign manage not to service? This managing container, again is a container. This time using the OSGI. Exactly.
So potentially, although not even potentially, this container, in theory, they're actually, but they can bring it with just through the rest of it.
Correct.
So that's how things we stand for. Could be.
Good one.
Or